Are you there? This is the debrief session. I want to hear how you did. Any comments? I'm still receiving some late submissions. I know it was tight. I imagine. Well, I don't know. I just start thinking about it. Maybe, yeah. It's 90 minutes you had, and then 15 minutes to upload. So, each question could have been at least 10 minutes of your time. You should have been able to do, with all your notes and everything, if you were organized, you should have been able to do the test in time. So, let me see who else is here. Do I have to send a notice that I'm on? Just a few people in. So I'll call this a debrief. Like the post-game show, Okay, comments. Hello, Fabiola. Norelis. Comments about the test. I really wanted you to write out your answers on paper. If you typed it, I really didn't want it typed. I thought it was pretty clear that I didn't want it typed. I wanted it written in your own handwriting. I have to check the prontuario if that's what I said. I don't think I wrote it explicitly, but things in this class it should be in your own handwriting, okay? Not in the computer. I intended first to make a multiple choice test, and I started to, and then it just took too long. So I decided just to give it like this. Yeah, my time is tight. So let's see, which questions did you pick? Which questions did you choose? Maybe I can put it up. I'm just getting set up here, sorry. Okay. I'm just getting the test. Was it hard? It was hard. Okay, let's see. I'm gonna I'm gonna flash the test. So, or like show you the test so that we can see which ones you did, which questions you didn't do. Just give me a moment. I had a connection problem yesterday too, or the other day. Let me see. I don't know why it doesn't connect. I never remember what I do to make this work. I think I had to reboot. I rebooted. So yeah, share your comments about the test. Yeah, time flies. Time really flies. Absolutely. You have to choose wisely. You have to examine. You have to practice enough so you can recognize questions for ones that you know and ones that you don't. How many of you had a good opportunity to go through the old midterms? There are a lot of midterms. There are a lot of midterms to practice. Maybe there are too many in the time that you had, but that can help you, certainly. Okay, rebooting. Yeah, you have to be very organized. So that test was only worth 10%. Okay, it wasn't worth a lot, and I'm gonna see how you did. Anyway, it's only 10%. It's not gonna. I mean, if you wrote it and you wrote something, you're gonna get some points, and you still can get an A in this class. You don't have to worry. Okay. So yeah, I'm sure you prefer multiple choice, but those can be hard too because time flies. You answer the questions, but you didn't necessarily do it right. Getting all your work is really important, I think, for learning and to find points for you. Let's see if it's not connecting again. Well, tell me, which questions did you do? Tell me the ones that you did. Let's see if there's a pattern. understand why it won't connect. Oh, I'll try one more thing. Yeah, which problems did you work on? How about which ones did you do well? Okay, so only 8, right? No more than 8, and you did them by hand. So I gave you a chance. If you didn't like one of the units, one of the topics, you could have avoided it completely. Yeah, I don't like to make the test depend on the computer because of if things can go wrong. So that's why I asked you to just download it, write it on separate pages. Can be very frustrating. Well, look at me right now, like this happens, and I don't know why I can't log in. I could probably just do this another way for now. So what I did was I rebooted the software. No, okay, mess, just forget it. I will just flash the the video. Sorry, not the video, the document. There you go. All right. So you tackled one. Right, so that's an easy, if you know the answer, that's a given. What'd you guys write for number 1? What did you write? Just yeah, you just had to write the name. So there, you just saved 10 minutes if you did that automatically. You could have put it towards a different question for question 1. So what'd you write for question 1? What was your answer? You guys scared? You don't want to write it. Okay. Okay. So a lead word, I say yes. Very good. So that's just one word, and you just got as many points as you did for a hard question. Some people might not like that approach, but it's like, it's up to you, you know. It's up to you to know what you know and what you don't know, if that makes sense. Okay, so yes, it's convenient sampling. Question 2. Lurking variable. The definition's right in your notes. Give the definition a simple random sample and make sure you get the whole definition. The difference between statistic and parameter. Give 3 examples of each. Interesting. It'd be interesting to read that. Let's see how many of you did number 2. You guys avoided it. You didn't like that question. That was right out of your notes. You just had to come up with examples. Three. Okay, who did 3? I'm just looking back. Who did 3? What did you say? Yeah, just refresh if you lose me. I think I'm good. I'll check the stream. No, I haven't had any interruptions since I've been on. Just refresh. Okay, so I was saying number 3. Who did number 3? You avoided number 3, most people, okay. Okay, so for this one, right, this is supposed to, so this is an example of a problem with using observation alone, where you want to develop experiments where you can test what has been observed. Like, it's part of the scientific method. You begin with observation. Now, observation, you can't attribute causality just purely from observation. You have to have some sort of control or some way of controlling for looking variables, essentially, right? That's what experiments do. So so the question was, which studies should we trust to reveal the truth about the effectiveness and or risk of hormone replacement therapy? If you have experiments done properly are the gold standard. Okay, they're better than observational studies. So it turns out with hormone replacement therapy, the fact is that the findings in observational studies are different from the findings in experimental studies. Hormone replacement therapy shouldn't just be given to every, it shouldn't be a certain dose for women in menopause. Cases vary, and it has to do with it turns out that the people who are doing well with hormone replacement therapy, the women who are doing well on it, are women who are more educated, who have higher incomes. These are women who have maybe some more extra leisure time to work on their health. Because hormone replacement therapy is very complicated. It's very individual. It has to be, it's just like not one pill or one size fits all. The person has to work with their doctor on finding the right dose and going repeatedly to the doctor. You have to have the means to pay for the tests and the drugs. So, or I should call them the hormones. So it is the case that in observational studies, it looked like women on hormone replacement therapy were doing really well, but when a experiment was created and people were randomized of all kinds of social and economic background, and they're randomized into either treatment and control group, it turned out that the people who are receiving the therapy, on average, had problems. They were had higher risk of breast cancer in particular. So that doesn't mean hormone replacement therapy is bad. It just means that it's not for everybody. It needs to be monitored, and the factors I mentioned play into the effectiveness of the treatment. and monitoring. You need to monitor. It should be someone who regularly gets checkups and blood tests, blood work done to avoid any complications. So yeah, if you said both, I said you to explain, so I'll see how you explained yourself. But that's a really, really good example. If you had time, you probably don't, but I have like a lot of videos, right? I did discuss that in one of my videos. So if any of you are really keen and want to listen to all my videos, you can get the answers to most of these things from the videos. Doesn't mean you're going to understand it and know where to find it in the middle of a test. But if you have extra time, if you get through the material I have on Moodle, that's your priority. Get through the materials I have and the videos I have on Moodle. If you have extra time, you can go into some older videos in the live stream. I really meant to do the timestamps. That would make it much easier for you too. I do have some timestamps for some of them. That way you can just skim through the topics that interest you. All right, so let's look at number 5. So people liked 5, right? It's called quantitative, so you went for it. Oh, where's 4? Gee. What did I do here? Let me see what happened to my number 4. So then that means there are less problems. 1, 2, 3. Must have deleted it by accident. No, there it is. Oh, what a mess. Oh, I know what I did. I remember now. I wanted it to fit on one page and I forgot about the numbering. Okay, whatever. I'll figure it out in the grading, which one you did. So 5, people did 5. 4, people avoided 4. I'm saying just by the people who show me what they did. Some of you avoided 4. Sorry. Okay, I'll read through your answers anyway. And okay, a lot of you did not do 4. So you have to set up the identify what all the different features of the experiment are. Explain how you would control or how control is achieved. And then comment on whether this is causal. I'd like to see what you had to say if you answer that. Question 6 was from some old midterms. I think I took it virtually from there. This could have taken you some time if you were not used to doing that kind of a problem. Let's see who did that. 6. No, you guys didn't like 6. Some of you did. Lots of 8. Let's see what's 7. 7's another quantitative one. Outlier box plot. 8 was, okay, so this should have been easy. That could have saved you time. So my recommendation is read through, identify the easy ones, and get those done and out of the way first, so you can guarantee those points. Okay, number 9. You guys tried how did you do number 9? So yeah, almost all those people did on. So how did you do number 9? You need the median. What was your approach? I'm sure you learned something doing this test, right? And that's what my hope is that it jars you awake, realizing what you know and what you don't know. Right, so extract from the graph the data. Okay, you can't look at the data here and conclude anything, because a time plot, that the fact that it's a time over time, that's not your variable. That's just showing different observations. If you flipped the axis, maybe you could see what to do, but really what you need to do here is extract the data from the graph and then calculate the median, put them in order. So make a list. The first one is 20. And then, we're approximating, but I'd say the next one was 17.5 about. And then the next one was 25. And then 30. And then 27.5. And then like 15, 16. That should be fine. I'd like to see what you did. And then 17.5 again. Maybe more, 18. I don't know, it looks like more like 18. I'll make it 18. Is that good? So 20, 17.5, 25, 30, 27.5, 16, 18. So taking those numbers, I'll take into consideration if you wrote slightly different numbers, and put them in order. Ooh, what happened? I have my file closed. My file closed. Oh my goodness. Did it disappear yet? It's still there, hey? Sorry, I'm just having... So yeah, I lost my numbers. Anyway, so then you put them in order and you find the center, and you guys are saying it's 20. I'm not going to do it. I'm not going to calculate it. Yeah, you do n plus 1 over 2, and you find it's the fourth. And that's how you do it. One minute. I need to update. There you go. All right. So yeah, that's how you do that one. The next one we did in class. Well, you saw this, we actually did this problem together. I don't remember if we solved this one, but we worked with this data in class. So you standardize to find the answer, find the proportion. And then The top 6% of gymnasts in any event can earn a trip to the national championship. What is the minimum vault score? So you have to use the vault data and do the backward problem for that. 11. 12 is also about the same problem, but now you're going to, oh, so this is the one we did in class where we standardize to see which one. I don't know, am I imagining? I think we did this in class or some variation of this question in class. So you would have to standardize to compare them. Oh, I don't know what's happening with my pantalla. Let me try. I'm going to just add another window. Yeah, my file just crashed. Better? Nope. It's crashed. I don't know. You hear me though? Refresh your Negra. Refresh. Refresh. Let me know how it goes. It gets very stuck. Question, so 11 and 12, all about the same problem from question 9. So those are easy. I think those are easy. And then I asked you a question about the normal distribution, number 13. Yeah, just refresh on your computers or reboot your computer. So this one's fun. Consider the normal distribution shown below. Which region has the largest area? So which is the largest area? And obviously, I mean, I didn't say explain, but for part marks, show your work, right? So is it the white, is it the gray, or is it the black? So if this is normal, what is the case? How many of you did this? Question 13. Some of you. Should I give you a minute? Let me give you a minute. Try that. I'm here, I'm just waiting to see if you guys try the problem. Oh, you just throw it together. Well, it's Okay, let's see. Be 34, right? That's 34%. And then also this gray is 34%. And then the black would be 95% minus 68%. So it's just using the 68, 95, 99.7 rule, but using the numbers in a different way. Knowing that rule, how can you figure out this areas, the probabilities of being in certain ranges? So the black will be equal to that. Within what? 2 standard deviations minus being within, the chance of being within 1. So that's going to be 27%. But also, you would have to divide it by 2 for each half, right? So then on each half, it will be 13.5. So I'm going to put 13.5% over here. And 13.5% over here. And then the white section, how much would the white be down here? That's going to be on both sides 100 minus 95. So this is just to practice the spaces of the normal distribution, practicing the rule that we know. So 5%. So then each white space is 2.5%. So if you answered this by color, the color with the largest area will be white. I don't know how you guys covered it. I guess I have to see. So you can't forget the white in the tails. Right, white with 39%. So white is 34% plus 5% in the tails. So it's 39%. All right, and then 14 about normal distributions. Working with the percentiles. And then about the uniform distribution. What's the uniform distribution? Did anybody do that one? Uniform distribution. It's not normal. It's different. Okay, Alvin, how did you do it? So the uniform is a box. You would have seen it in old midterms. I think I tackled it in some of the exams. So very good. So you know how to do the uniform then. So for the others, I'm going to show you how to do this problem. The uniform distribution is not like the normal. It doesn't involve a table. It's a very common shape that you should be able to work with because it's just a box. That's not working. Oh, because so yeah, I understand computer problems because mine is disappointing me right now. It's not connecting. Okay. Go away. All right. So that is the uniform distribution. It's a rectangle and it goes between. So this is useful when being, okay, well, let me write the numbers down first. So between 37 and 84, so let's say I'm completing a test. You can say a standardized test or this test that we just did. Completing a test, the time to complete a test in minutes is a uniform distribution. Let's say it was. If it was, then the chance of completing the test between 37 and let's say this is 45, and then an equal distance on the other side, so between 45 and 37 are 8. So let's say this was 76. So uniform distribution would say that a person is just as likely, because this is the density curve here. It says that a person is just as likely to take between 37 and 45 minutes as they are. Uh-oh, it's going to crash again. It's going to crash. Do you guys still see me? Okay. I just got a notification that it was going to crash. All right, so it's just as likely to be that range. So that's just 8, a difference of 8. Minutes. As it is to be 84 minus 76 equals 8 as well. So it's uniform in that sense, that this area in here the area between these two is the same as the area oh, it's just not doing what I want. Well, just as likely as the area between these two, okay? So we don't know, we know the range is from 37 to 84, and we know that the total area is equal to 100%, right? 1 under the curve. So this is really this is testing your understanding of density curves, that it has to be 1 underneath. So that means that the height must be what? How do we figure out the height? So the total area of any of the ranges that you're going to take, this is a continuous distribution, so it's like a normal in that sense. I can only calculate probability or density between 2 points. So the area I could calculate because it is a rectangle, and portions of it just make rectangles. The area is just height times width. So what about the total area? We know the total area is also height times width, and it must be equal to 1. We know the width, so we can solve for the height. The width would be 84 minus 37. So that's why, who wrote in the chat, Alvin is talking about B minus A. Those are the parameters. So see how this is similar to the idea of a normal distribution. The parameters for the uniform are A and B, or lower and upper bounds. Okay, so it's just knowing, basically knowing the lower and the upper bound, you know everything about this distribution and how to make predictions around it, because everything revolves around solving what we're solving right now. Yeah, some people will say A to B. So height times 84 minus 37 is 47. So that means that the height must be 1 over 47. In general, for a uniform distribution, the height is always 1 divided by B minus A, or upper minus lower. I prefer to use upper and lower. No, we didn't cover it in class, but it is in the exams. Not everything I cover in class is all you need to know. You have to go through the tests and exams and practice. You should know about density curves. This is a basic property of density curves, and I think in elementary school you learn how to calculate areas. So all these extra details that I'm telling you now, you wouldn't really need to be able to solve this. So so 1 over 47 is the height. So then if you want to figure out this here, just for a portion of it, and get 2872, what is the upper limit on that portion? So 48.2 is somewhere in here. And then the unknown is somewhere. I'm not going to be able to draw anything else on there for some reason. But okay, so basically I'm just figuring out where it is to go from 48 to where in order to get 28 in the middle. So this is the B that I want to find. Okay, and we could call this one 48.2. Say this is 48.2, and you want to find what B is so that this area is exactly 28. .2872. So all we're going to do is repeat the calculation of the area. So as I explained before, I teach you a tool and then you just keep using it. You just keep using the same tool. It just seems weird, like I'm repeating it, but I'm going to do the same thing. Now I'm going to call it the area is equal to 0.2872, and the height times the width. The height I already know. Because it's the same always. The height is 1 over 47. Put it in brackets. Oh, that wasn't very good. And the width, how will we get the width? Well, the same way as we did before. Upper minus lower. The upper one is a B, and the lower one is 48.2. And I know that this is in order because this is the smaller value. I'm almost done. You guys are going to leave in a minute. This is a smaller value, and the sign here goes small to big and then small to big. So it's going from small to large numbers. So what you have to do here is solve for solve for b. So what should b be? So I'm going to multiply this by 47 because it was in the denominator over there. And this is equal to, I'm going to get rid of this multiplication so it doesn't look like another letter. So those are just being multiplied. And then this is b minus 48.2. And then so finally b must be 48.2 plus whatever 47 times 0.2872 is. The 62. And that's the answer. Did anybody get that? You can brag, or you can tell me I got it wrong. Did I make a mistake? Oh, 61.7. Okay, about the same. Very good. So you guys got it. So people who've never seen that before, there it is. But that was, I think there were exercises like that on the old midterms. And I'm trying to think if there was in the notes. But anyway, it's testing your knowledge of a density curve. Okay, so it's 10 to 9. Unless you have any questions, you guys can go. Have a good night, and I guess start working with the regression material. We'll pick up with the regression material next class. And so that's unit 3. Okay? So I'll stay back if anyone has any questions. Thank you, everyone. Good night.